respected judges, eminent scientists, and viewers of my presentation. Today, I am here to present our research work entitled Preclinical Pharmacokinetic Study of Niclosamide and Bicalutamide, a novel combination for prostate cancer using a validated UHPLC cute of MS method. This is a first-hand report on a validated LCMS method for the concurrent quantification of niclosamide and bicalutamide in rat plasma. The developed method was applied to the in vivo pharmacokinetics of both the drugs in Sprague-Dawley rats. The developed method has a short runtime and a simple sample preparation approach. The method demonstrated a sensitivity of 1 nanogram per ml for both niclosamide and bicalutamide. Coming on to the rationale of this developed method. Prostate cancer is a kind of cancer that affects the prostate gland that generates the seminal fluid. In 2018, American Cancer Society reported 164,690 cases and 29,430 deaths due to prostate cancer. It constituted around 4.8% of all cancer deaths. Niclosamide is an effective anthelmintic which also used for the other ailments like SARS and schistomiasis. Bicalutamide has also been widely used as a first-line approach for the therapy of prostate cancer. In 2017, Liu et al. Had an interesting finding, a combination of bicalutamide with niclosamide which suppresses tumor growth of enzalutamide-resistant prostate cancer. Their in vitro and in vivo findings indicated that this combination has a potential therapeutic efficiency to treat advanced prostate cancer. This combination may provide a potential and effective strategy to treat advanced prostate cancer which fails to respond for enzalutamide-resistant prostate cancer. This finding also could have a clinical significance towards the management of metastatic castration-resistant prostate cancer. Our aim and objective was to develop and validate an LCMS-based bioanalytical method for the concurrent estimation of niclosamide and bicalutamide in rat plasma, and then to explore the in vivo pharmacokinetics of both the drugs in Sprague-Dawley rats. Coming on to the plasma sample preparation, here we had utilized protein precipitation method as a sample preparation approach for this entire method, both for the QC sample as well as the real-time samples. Here, 45 microliter of thawed plasma was taken and 5 microliter of the working standard solution was spiked. And then we had added 150 microliter of the composition acetonitrile methanol as a protein precipitation agent in the ratio of 50:50. To this, we also added 50 nanogram per ml of internal standard, which is letrozole. Vortex for 1 minute and centrifuge for 5 minutes at 9168 G. The supernatant was collected and 1 microliter was injected to LCMS system for further analysis. The chromatographic and instrumental condition. Here we had tried with different columns, and among these columns, Agilent Poroshel C18 column had given an excellent resolution for all the 3 analytes. We had used a gradient program consisting of 0.1% formic acid and acetonitrile at a flow rate of 0.45 ml per minute at a total runtime of 4 minutes. We got a retention time of 3.085 for niclosamide and 2.084 for bicalutamide and 1.563 for the internal standard. Here we had utilized Agilent QTOF LCMS 6540 series, and we had tested it in both positive ionization mode and negative ionization mode, and negative ionization mode had given excellent intensity for all the 3 analytes. The figure A shows the representative mass spectra of niclosamide, and figure B shows the representative mass spectra of the bicalutamide, and the figure C is a internal standard mass spectra. The optimized and developed method was validated according to US FDA Bioanalytical Guidelines 2018. We got a calibration curve of 1 nanogram per ml to 500 nanogram per ml with excellent correlation ratio of 0.9942 to niclosamide and 0.9952 for bicalutamide with 1 by x square weighting, and the LLOQ value of 1 nanogram per ml. It indicates that we are having a sensitivity of 1 nanogram per ml. 3 nanogram per ml was utilized as a LQC sample, and MQC of 40 nanogram per ml and HQC of 400 nanogram per ml. This is a calibration curve for niclosamide and bicalutamide, and the method found to be selective and there was no carryover effect was observed. This is an extracted ion chromatogram of blank plasma. This is an extracted ion chromatogram of blank plasma on the left hand side, and the right hand side it is our samples at LLOQ level. And this is a QC samples at MQC, LQC, MQC, and HQC for both niclosamide and bicalutamide. The method found to be precise and accurate. Both intraday and interday studies were carried out. We got an excellent recovery and there was no matrix effect was observed. We got a recovery of 92 to 97% for the niclosamide and 91 to 95% for the bicalutamide and 90% for the internal standard. And the matrix factor was found to be within limits. We had performed the stability studies at different storage conditions. At 4 different conditions, the first room temperature for 6 hours and 3 freezer cycles, auto sample stability studies at 10 degrees Celsius for 24 hours, and long-term stability study at minus 80 degrees Celsius for 1 month. All the QC sample of niclosamide and bicalutamide found to be stable under all these conditions. The Rogers study was performed between the 2 analysts and the method found to be rejected. Coming on to the in vivo pharmacokinetic study, we had taken 3 groups of ST rats consisting of 6 XD rats per each group, and the first group is dosed with niclosamide 5 milligram per kg, and the second group with 25 milligram per kg of bicalutamide, and the third group with 5 milligram per kg of niclosamide and 25 milligram per kg of bicalutamide. And the PK parameters were taken at 11 time points, and the PK parameter was tabulated and evaluated with the help of Phoenix Minoling software. The PK parameter tabulated shows a 369.96 Cmax value for the niclosamide at a Tmax of 0.5 hours and 2341 nanogram per ml for our bicalutamide at a 7.33 Tmax value of 7.33. And in both the third group, both drug combination, there is not that much difference was observed. The left hand side, the PK plot of niclosamide individual as well as in combination, and bicalutamide individual as well as in combination is given. In the downside, extracted chromatogram of real-time samples or niclosamide, bicalutamide, and internal standard at Cmax is given. And coming on to the summary, in the study, a rapid, sensitive, accurate, and rugged UHPLC QTOF method was developed, which was established and validated and successfully applied to study the simultaneous quantification of niclosamide and bicalutamide from rat plasma. The method demonstrated a sensitivity of 1 nanogram per ml and a linearity over a calibration range of 1 to 500 nanogram per ml in rat plasma. We had utilized a simple sample preparation approach, a protein presentation, which avoided laborious and time-consuming procedure for the sample preparation. This is a potential combination, so the formulation scientist can utilize this combination to develop a novel formulation to treat advanced prostate cancer. So this method can be utilized by the scientists working on these drugs for the bioanalytical quantification of these drugs. So this preliminary PK study will provide an helpful information for further exploration of this promising combination against prostate cancer. These are my references. I thank the eminent panel of judges, eminent scientists, and viewers of my presentation, and also the organizers for giving us this wonderful opportunity in this online platform to present our research work. Thank you.